All right, here is our last part of our function review. We've got some A-level questions that are allegedly a little bit harder than some of the other ones. So let's try it. So a child tosses a baseball up into the air. On its way down, it gets caught in a tree for several seconds before falling to the ground. Sketch a graph that represents the height of the ball h as a function of time t. So this is h, and then this is t. I can imagine that the child is a couple feet tall. Maybe the child is, say, 4 feet tall. So that's like the top of their head. And they toss the ball. Let's just pretend they toss the ball from their head height. So the ball flies up in the air, and then on its way down, it gets caught in a tree for several seconds. Notice that the x-axis is the time. So if it gets caught in the tree for several seconds, it's going to be caught means at the same height. So that's why I drew a horizontal line, because it's at the same height for a couple seconds, and then it falls to the ground. So if it didn't get caught in the tree, we would just see like our normal arc through the air of a ball flying through the air. That would be just like it's called a parabola. We'll study that later in this unit. But because it got caught in the tree, it's like I took this part of the parabola and I just slid it over like that. So that's kind of where I came up with the shape. So he said, sketch a graph that represents the height of the ball h as a function of time t. Be sure to include a label and a scale for each axis. So this is t is time, and that's measured in seconds. H is the height, and let's measure that in feet. So if that's 4, there's 3, there's 2, there's 1. And then same idea, we'll say 1, 2, 3, 4. Maybe after, that's a pretty big throw. We're just going to say this kid's got quite the arm on him. 1, 2, 3, I guess, or her. 5 seconds to be at its maximum height. On its way down, 6, 7, maybe at 8 seconds it's at the tree. Then we got 9, 10, 11 seconds. It keeps going down. 12, 13 seconds, like that. Okay? Now include and identify the domain and range. So for this one, the information in the paragraph doesn't tell you what the domain and the range are. It just tells you to draw a possible graph here. So you need to think about what is reasonable about this situation. 13 seconds of airtime is a bit long, to be honest, but if you're going on a test, I'm okay with it being 13 seconds of airtime. I'm not okay with it being like 100 seconds of airtime. But any relatively small number can be okay for throwing a ball in the air, especially if it gets caught in a tree for a few seconds. So the domain here is all the possible times that are in between 0 and 13. I used the letter T because that's how I labeled my x-axis, with the letter T. If you want to use the letter X, I'm not going to knock off any points. If you want to write out the sentence, all the numbers between 0 and 13, that's also okay. The range is all the possible y values. Here I'm talking about h. I can see that the ball hits the ground eventually, so I can go 0 is less than or equal to h. I need to make up a maximum possible height. If this is 4, then we can kind of keep counting. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we'll say about 14 as the maximum height. Again, the ball wouldn't really go up to 14 feet. It would go higher than that. But we haven't really studied that type of equation yet this year, where we figure out exactly how high the ball goes in a certain amount of time. So all I really need for the purposes of this test is just like a reasonable number. So don't say the ball went 1,000,000 feet in the air, because it's just a child throwing a baseball. Don't say the ball went only 1 foot in the air, because the child threw the baseball up and then it was in a tree. So 14 to be honest, is a little bit on the small side. So maybe I should have drawn a better graph and said like the maximum height was like 40, something like that's a little bit more reasonable, maybe 30. But 14 is okay, just like how 0 to 13 is okay. All right, I'm going to do one more thing on this problem, even though it did not ask me to. I'm just going to remind you guys that like this point right here, the y-intercept is the point 0, 4. I can write it, oh, why is it doing that? Sorry about that. I can write 0, 4 using function notation like this, h of 0 equals 4. I decided that this maximum point is at 5, 14. I can write that as h of 5 equals 14. All of these points right here are at about 10. So I could say like h of 8 equals 10. Or I could even say something like h of 8 equals h of 9. That means that the height at 8 seconds was equal to the height at 9 seconds. And then down here, I can say that h of 13 equals 0. Just want you to see a few more examples of using function notation to represent a point. All right, my thing's being a little weird, but we'll stick with it. Okay, down here, match each equation with the graph that represents it. This is, if you know what an absolute value graph looks like, this is not a very hard problem. But if you don't know what an absolute value graph looks like, this can be a very hard problem. So the reason we put this on an A level is because I want you to be able to look at a new type of an equation and figure out how the graph should look. Because the graph is just all the points that are solutions to the equation. So what you can do on all of these is just try out the number x equals 0. And let's see what happens. For the first equation, I go 0 minus 3. Think about what 0 minus 3 is. That's negative 3. And then the absolute value of negative 3 is positive 3. So I know that on one of those graphs, there should be the point 0, 3, which I could also write as f of 0 equals 3. Okay? There are two possible graphs that work here. This graph right here, 0, 3, and this graph right here, 0, 3. So just by plugging in the number x equals 0, we've narrowed down which graph it is. Let's just try one other number. How about x equals 3? Maybe I'll use a different color for this. So let's try x equals 3 in that same first equation. It says y equals x, 3 minus 3. 3 minus 3 is 0. And the absolute value of 0 is 0. So now I'm looking for a graph that also has the point 3, 0 on it. This graph has 3, 0, and this graph has 3, 0. The only graph that has both of those is this one. So I know that this one is the graph that's called A. Okay, now let's go back and try x equals 3 in our equation B. Let's try absolute value of 3 minus 6. Absolute value of 3 is 3. 3 minus 6 is negative 3. Which graph has a point at 3, negative 3? Just this one. So I know that this is graph B. Let's try graph C. I'm going to keep going with x equals 3. Not that I have to. I could have chosen any number that I'm able to compare to the graph. Like, don't choose x equals 17, because that's not on the graph that you can see. 3 plus 3 is 6. Absolute value of 6 is 6. 6 minus 6 is 0. So now I'm looking for a graph that has the point of 3, 0. There's this one here, but we already know that one's A. There's this one over here, so that has to be C. And then by process of elimination, you can see that this one has to be D. Okay, so if you know how to do this type of problem, then it's probably not an A-level question. But if you've never seen an absolute value graph before, then you need to think, what does a graph mean in the first place? And what a graph means is it's a picture that shows all the points that are solutions. And the way you find a solution is you choose any x value, plug it into the equation, and get your y value. Every pair x and y that works with the equation is a point on the graph. So the graph is just the picture that shows all the solutions to the equation. Come on, why is this being weird? There we go. All right, last one, I believe. Graph the function h of x equals x minus 1 squared minus 3. Same sort of comment as I just made. Like, if you have done a lot of this type of graph before, this is pretty much a routine problem. Just like if I asked you to graph y equals mx plus b. You know the process, you just kind of go through it. If you've never done one of these before, it's pretty tricky. So let's see what happens. Let's try to make a table. X and y. Let's start with x equals 0, and then we'll go to x equals 1, and then we'll go to x equals 2, and we'll just see if we need to do more after that. Okay? Let's start with 0. I'm going to have you guys see how I do it just using a calculator. On the absolute value one, I did it by hand, but there's no reason to do that. So look, I just typed in x equals 0. So the equation was x minus 1 squared minus 3. So I just typed in 0 minus 1 squared minus 3. Yes, the parentheses matter. Please put the parentheses on there. So I get negative 2. So I can put a dot right there. Next one, I'm typing in 1 minus 1 minus 3. So I know that, the point 1 goes to minus 3. Then we go to 2 minus 1 minus 3. And I get negative 2 again. So we have this weird thing where the graph is dipping down and going back up. Let's try a couple more. Let's try x equals 3 and x equals negative 1 and see if we can kind of find a pattern. The reason I chose those is because they are just one step in either direction further away. So notice what I did is I typed both of them in and I got the same answer of positive 1. So what I'm noticing is that if I go one step to the right, the graph goes up here, and if I go one step to the left, the graph also goes up there. So I'm kind of filling in the smiley face. If I went one more step to the right, I would be at x equals 4. And you can see I get y equals 6. And I'm going to just assume that we get that same sort of symmetry on the other side. And I'm just going to assume it keeps going up on either side. There's the graph. Let's identify the domain. Is there anything happening here that restricts the x's that we can plug in? In other words, is there any reason we can't plug in an x value? If you look at the equation, there's no problem. I could plug in big x values, 0. I could plug in decimals. I could plug in big negative numbers. So the domain, you can write it a couple different ways. You can say all numbers. I'd be okay with you writing all numbers. Or you can write it like this. X is between negative infinity and infinity. Or you can just say x is all numbers if you don't like the inequalities. Look at the range though. I am not getting every number back out as an answer. There is a bottom number on my graph. The lowest y value that I get to is negative 3. So negative 3 is less than or equal to y, but there's no top number. You can leave your answer like that, or you can remind everybody that we're not going to reach infinity. Only Buzz Lightyear can do that. All right, that's the end of the review. Please let me know if you've got any questions. Happy to help.